Hi everyone, I'm Brianna Gopaul, and I've been deeply focused in natural language processing and deep learning. Unfortunately, my socks aren't nearly as cool as the socks that Ed had, but I think my talk will be pretty interesting anyways. So this summer, I flew all the way to Vancouver to work for this crazy company called Sanctuary AI. And to be honest, on the flight there, I was freaking out. For two main reasons, that is. First of all, Sanctuary is working on building these. Yeah, they look pretty crazy. Actually, this one is named Nadine. She became my best friend after 2 months. I mean, here's a selfie just to prove it. But the second reason that I was so nervous was because I'd be working with this algorithm called GPT-2. And upon searching up this algorithm on the internet, I got headlines like this, and this. Basically, the media sees GPT-2 as this crazy text generator that's going to spew massive amounts of fake news on the internet. And to be completely honest, they're not entirely wrong. GPT-2 is really good at generating fake human realistic text. And just to prove to you how good this algorithm is at doing this, we're going to be doing a mini variant of the Turing test right here. So I have these 3 pieces of text up here. And I want you to distinguish which ones were generated by a human like me and which ones were generated by the algorithm. I'll give you a couple of seconds. All right, dope. So, haha, joke's on you. Actually, all of these pieces of text were generated by GPT-2. And this is why the media is so concerned about this algorithm. It's really good at creating fake human realistic text. I mean, we already know that fake news is on the rise, but this algorithm just automates the process of creating fake headlines, fake stories, and fake articles. And soon later, it will then be able to distribute all of this fake content through platforms like social media and news outlets, so that we'll be able to generate fake content and spread it all over the world in a matter of seconds. And if we don't start thinking about ways to solve this problem right now, what we're going to see is the internet transform into this chaotic mess where we won't be able to distinguish real information from fake information. Now, the first step that we need to take in solving any problem is to really understand the root cause of this problem. So I'm going to break down how GPT-2 actually works. So the algorithm takes in some text as input, and then it starts to understand the underlying structure of that text, and then it predicts what the next word will be in that sentence. Now, the first part of this process is something called a word embedding, or in this case, a positional encoding, where it looks at every single word that's in the sentence, and it encodes the position of that word in that sentence. So let's say that I have 2 sentences like, I like cats, or I cats like. These are 2 very different sentences that mean completely different things. And that's exactly why we want to encode the position of every single word in that sentence. Now, the next step in this algorithm is to pass this word embedding to a transformer. And I'm not talking about like Optimus Prime, that type of transformer. We're talking about a neural network architecture. And this transformer really just contains a bunch of decoder blocks and feed-forward neural networks. And each decoder contains something called an attention mechanism. What this attention mechanism does is it looks at all the words in that sentence, and it says, okay, this one's super important, this one's not as important, and this one is super important to the meaning of the sentence. After this word embedding is passed through the transformer, the algorithm then outputs a bunch of probabilities that are associated with every single word that it knows. So in this case, it has these weird random words that you see here. And I'll say, okay, I think that the next word in the sentence, there's a 50% probability of it being this, and a 30% probability of it being this. And the algorithm will pick the word with the highest probability as the text output. Now, it's perfectly fine if you didn't understand anything that I just said. It's okay, I didn't really understand it at first either. So I'm going to break it down for you in an analogy instead. We can kind of think GPT-2 as working like a factory that produces counterfeit clothing. In this case, my factory produces Gucci t-shirts because we're fancy. So one of the machines in my factory just looks at every single Gucci t-shirt and it identifies all the important components in this t-shirt. Maybe the logo or the Gucci logo of this t-shirt is super important, or the color of this t-shirt, or the structure of the t-shirt and how it actually looks. Once it really understands the structure of that t-shirt, it then has another machine that just replicates what that t-shirt looks like to create a counterfeit version of our Gucci t-shirt. And that's kind of what GPT-2 is doing, because it first understands the underlying structure of a sentence, and then it tries to extend that sentence by predicting the next word in that sentence. That's kind of what GPT-2 is actually doing. Now, as we add more and more parameters to this model, the model gets better and better at generating fake human realistic text. Currently, OpenAI has 4 different variations of this model released right now. A smaller model that has 117 million parameters, and the largest model that has 1.5 billion parameters. And right now, OpenAI has only released the first 3 smallest models because of the massive threat that this algorithm poses to the security of the internet. But this decision is actually fundamentally wrong. Instead, what we need to be doing is releasing this largest algorithm so people can start understanding how to use it and creating preventative solutions and measures to make sure that algorithms like GPT-2 don't wreak absolute havoc on the internet. When you think about every single problem that has been solved in history, it was really just a combination of 3 things. First, crazy smart nerds. Second, a deep understanding of that problem. And third, an emotional or economic incentive. I mean, let's just look at polio, for example. In 1988, there were 350,000 cases of polio. Then the US government was like, okay, I'm gonna invest $235 million into this problem. So they invested all that money into research to better understand how this polio virus actually worked. Then they flew out thousands and thousands of crazy smart nerd doctors to countries all around the world to prevent polio from spreading. And today, in 2018, there are only 35 cases of polio. That just shows that for a problem to be solved, it's really, once again, these 3 things. Crazy smart nerds, a deep understanding of that problem, and a strong economic or emotional incentive to do so. And so we really need to start shifting the way that we're thinking about algorithms like GPT-2. Instead of taking these scary algorithms and locking them in dungeons somewhere far away, we actually need to shift our mentality towards, okay, I'm gonna release them to the public so that I can have a bunch of crazy smart nerds start working with them and tinkering with them in weird ways, so that we can actually start thinking about solutions to solve these types of problems. If you took away anything from this talk, I really want it to be these 3 points. First of all, algorithms like GPT-2 and similar language models have the potential to basically wreck the internet as it is by itself. Second, our current approach towards solving these types of problems doesn't make sense. The real way to solve any problem is to combine crazy smart people plus a deep understanding of that problem, and then a strong incentive to solve that problem. And third, to really start making sure that algorithms like GPT-2 don't wreak havoc on the internet, what we need to do instead is to release these algorithms to the public so people can start playing around with them now and start thinking about proactive ways to make sure that these algorithms don't mess up the internet. Thank you.